All right, so for today's lesson, we are going to do factoring by GCF, by greatest common factor. What you need to understand is that in order to find the greatest common factor of numbers, you want to find the largest number that divides evenly into all of the numbers. Okay, so the GCF for a number is the largest number that divides evenly into all of the numbers that are there. For variables, it's a little bit different, and it kind of sounds weird, but the GCF for variables is actually the smallest power, the smallest exponent of all the common variables. So for variables, you're looking for the smallest power, smallest exponent, right, of all common variables. So if I were to look at this first example in terms of 12x squared, 48x, and 36x cubed, in terms of the numbers, the number that would divide into all of those, the biggest number would be 12, right? So 12 divides into 12 evenly, 12 divides into 48, and 12 divides into 36. Basically, your GCF, as you're looking for it, has to be not any bigger than your smallest number. Hopefully that makes sense. In terms of your variables, I'm looking for the smallest power of the variables. And I have an x squared, an x, and an x cubed. So my smallest power would be my x to the first, which means the GCF would be 12x. Let me show you something about the variables and see if this maybe also makes sense. If I were to take the 12, I know that I have x squared, or I've got x times x. If I looked at the 48, the variable attached to that is x. If I looked at the 36, it's x cubed. So essentially, I've got 3 x's. Well, I need to know how many is common to all of them. I essentially have one set of x's common to every single value. That's why that one set, or x, is my GCF. Okay, so it's 12x. When I look into the next one, when I look into 18 and 24, well, what's the largest number divisible by both of those values? Well, 18 doesn't go into 24. So if I start breaking down the factors, I'll find out that 6 is the largest number that divides evenly into 18 and 24. So right now for my numbers, my GCF is 6. Well, let's look at the variables, and maybe we'll do it by the list method. That might be easy. So 18 has a squared and b. 24 has a squared, b squared, and c. Well, I need to find things that are common to both. I've got a set of a common to both. I have a second set of a common to both, and I've got a set of b. So essentially, I'm looking for just those common variables, a and b. The smallest power of a is a squared, and the smallest power of b is just b. In other words, there are two sets of a's, a squared, one set of b. So the GCF for that number 2 would be 6a squared b. When we try to factor, what we're looking to do is find the GCF of the entire polynomial. You're going to divide all the terms of the polynomial by the GCF. It's almost like reverse distribution. And you're going to check your answer. Now, your answer should always be written as follows. It should be whatever the GCF is outside of the polynomial, because the way that you check it is by the distributive property. So if I take a look at number 3, my GCF, well, my number that can go into both of them is 9, and the most x's I can take out at a time is x. So my GCF happens to be 9x. So that's what I'm going to divide everything by. So my answer becomes GCF outside of, well, 9x divided by x squared is just x. And then I've got a plus sign. And then 36x divided by x is just 4. So this should be my answer, 9x quantity x plus 4. And is that right? Well, sure, because when I multiply back, 9x times x is 9x squared. 9x times 4 is 36x. So this, in fact, is my final answer. Let's take a look at 4. My GCF, well, I don't have any variables as a GCF. In terms of, if I look at my x's, x's is not common to both. Y's is common to both, but the most I can take out one time is y cubed. So my answer becomes y cubed, and I can open up a parenthesis. If I divide 15x cubed by y cubed, what's left over is 15x. If I divide y to the fourth by y cubed, what's left over is minus y. Because multiplying back, 15x times y cubed is, and here's what I'm kind of saying, if I were to multiply this back, y cubed times 15x, 15x y cubed. Y cubed times negative y to the fourth. This, again, is my final answer. GCF outside your polynomial. Number 5, GCF. There are no numbers except one, but in terms of variables, the common variable is y, and the smallest power is just y. So my answer becomes y, open up a parenthesis. Well, y divided by y is just 1. Minus minus. Xy squared divided by y is just xy. There's your final answer. Again, you can multiply back and you'll see that you'll get the answer that you need. On number 6, in this case, what's a little bit different about this one is that your lead coefficient, your lead-off term, happens to be a negative. So we tend to have our GCFs be the same sign as whatever the first number or the first term of our expression is. So in terms of values, GCF, I'm going to have negative 10 be the number, and in terms of common letters, it's going to be C. So I've got negative 10C as my GCF. If I divide this by negative 10C, what's left over is just a B. And if I divide this by negative 10C, what's left over is just a negative 1. So negative 10C times B is negative 10CB. Negative 10C times negative 1 is positive 10C. So here's the answer. The next one, in terms of my numbers, 20, 12, and 32, my GCF in terms of values is a 4. In terms of variables, they all have x's, but the least power is x squared. So my common factor, my GCF is 4x squared. When I divide 12x to the fifth by 4x squared, I get 3x cubed. When I divide negative 20x squared by 4x squared, you get negative 5. All the x's, they're done. And when I divide 32x4 divided by 4x squared, you get 8x squared. So here's your final answer. 4x squared times the quantity of 3x cubed minus 5 plus 8x squared. Next one, 28, 21, and 14. My GCF in terms of those numbers is a 7. That's the biggest number to get out. A's are common to both, but the smallest power of A is A squared. B's are common to both, but the smallest power of B's is just B. So I'm just going to kind of drop this down over here, actually. So it's going to be 7A squared B. And when I divide the first term by 7A squared B, I'm left with 4B. 21A squared B divided by 7A squared B is just positive 3. And then negative 14A cubed B squared divided by A squared B becomes negative 2AB. Final answer, 7A squared times the quantity of 4B plus 3 minus 2AB. 9. Pi r squared plus 2 pi r h. There is no number GCF, but there's a letter GCF and actually a symbol GCF. So pi is a part of both. It's a common factor. And r, but just r, not r squared because it's the smallest power. So pi r is the GCF. When I divide that by pi r, I'm left with just r. When I divide that by pi r, I'm just left with 2h. So pi r times r plus 2h, final answer. GCF of this next one, as I go through, they all have the letter K, but that's all that they share. So my GCF is K. So K comes outside of parentheses, which means x to the fourth is left over. K comes out, minus 2x3. K comes out, plus 4x squared. And K comes out, which is minus 1. Don't forget, something divided by itself is not 0. It just happens to be a 1. In this case, it's a minus 1. This one looks a little bit different because there happen to be 2 parentheses here, but notice that the parentheses, the binomials are the same. So your GCF is that common binomial. So your GCF is the parenthesis x plus 2. So the x plus 2 comes on the outside of a parenthesis. Well, what happens when I divide this by x plus 2? Those cancel. I've got the 5x left over. What happens when I divide this guy by the x plus 2? Those cancel, and I'm left with minus 3. So now your answer is a GCF, which happens to be a binomial GCF, outside the parenthesis. Same idea, don't let that throw you off. And again, if you take a look at this next one, well, the common factor is the y minus 1. So my GCF is y minus 1. But when I divide that, I'm left with 2y squared plus, and when I divide this, I'm left with that plus 9. So basically what happens when there's binomial GCFs is you get rid of those binomial GCFs, and then what's left over is what's on the outside of the parenthesis. Got 2 more to go. So this one, your common denominator, or sorry, your GCF, your common factor, is x plus y. When I divide it out, I'm left with 4. When I divide it out, I'm left with minus 3x. So x plus y, and then 4 minus 3x. This last one, same idea. A squared minus 1, a squared minus 1, a squared minus 1. So the GCF is a squared minus 1. What's left over is going to be ab plus c minus 3. Right? Because I'm going to divide out the parenthesis. I'm going to divide out the parenthesis. I'm going to divide out the parenthesis. So we're left over here with a bi and a tri. Okay? So it's all factoring by GCF. You're going to find the GCF of the entire polynomial. That could be numbers and or letters. You're going to divide out that GCF, and you're going to be left over with some other polynomial. Good luck on your homework.